Hi everyone, I'm Clarissa Ida Marie Alpam and I'll be presenting our topic, which is the Chapter 3 a Statistics Refresher. When we speak of measurement, it is defined as the act of assigning numbers or even symbols to the characteristics of things according to rules, which, when numbers are assigned, it is the guidelines to represent the size of what is being measured. On the other hand, scale is defined as a set of numbers whose properties model the empirical properties of the object to which the numbers are associated. Measurement scales relate to the way the variables or the numbers are defined and categorized. So each measurement scale has certain properties that in turn determine its suitability for using certain statistical analysis. Nominal, ordinal, interval, and ratio are the four common measurement scales developed by Stanley Stevens to define and categorize variables. Nominal scales of measurement. So this type of measurement scale can be considered the simplest than the others. The nominal scale is also known as the categorical variables scale because it implies a classification and categorization based on one or more differentiators in which the measured variables are categorized. Calculations with these variables are meaningless as there is no numerical value for options. Some of the variables that use a nominal scale can be location, religion, gender, etc. So let's look at this example, where the students in a class can be divided into two possible classes, namely the male and the female. Nominal data can be broken down again into three categories. 1. Nominal with order. Some nominal data can be subcategorized in order, such as cold-warm, hot, and very hot. 2. Nominal without order. Nominal data can also be subcategorized as nominal without order, such as male and female. And lastly, dichotomous. Dichotomous data is defined by having only two categories or levels, such as yes and no. Ordinal scale of measurement. So this type of measure is an opinion measure, and the standard deviation and mean in this type of measure are not valid as a measure of central tendency. Here, the variables are arranged in an order, but only allow the measurement of the value as a minor or major scale, and this scale cannot make an exact comparison between the two categories, or there is no information indicating what the categories are from. Therefore, ordinal scales do not have an absolute 0 point. Ordinal scale could be a movie ratings. For example, students in a class could rate a movie on the scale below. So, note that the difference between a movie with a 5-star rating and a movie with a 4-star rating cannot be quantified and may not be the same as the difference between a movie with a 4-star rating and a movie with a 3-star rating. You just can change the order of the classes. Scale, it is possible to average a series of measurements and obtain a meaningful result. The difference between data points can also be quantified in this type of scale measurement and can show the exact difference between variables. For example, the test intelligence can be analyzed statistically in ways appropriate for the data at the interval level of measurement. Take, for example, the difference in intellectual ability represented by IQs of 80 and 100 is thought to be similar to the difference of IQs of 100 and 120. Though if an individual were to achieve an IQ of 0, it would not be considered as 0 because not just it's impossible to get 0 given most of intelligence tests are structured. Interval scale also does not contain an absolute 0 point, and there's a presumption inherent in their use that no test taker possesses none of the ability or trait being measured. Ratio scale of measurement. The data on the ratio scale are defined by an identity, just as in nominal. It can also be classified in sequence. It can be divided into precise values, as in the interval. and it can also be classified in the sequence as in the ordinal number. What distinguishes it from the interval is that this type of scale measurement has a true zero, which means that the number zero corresponds to data that has no value or quantity. So there is an instrument called dynamometer, which is used to measure strength of a hand grip. The examinee is instructed to squeeze the grips as hard as possible. The squeezing of the grips causes the gauge needle to move and reflect the number of pounds of pressure exerted. The highest point reached by the needle is the score. This is an example of ratio level measurement. Someone who can exert 10 pounds of pressure and earns a score of 10 exerts twice as much pressure as a person who exerts 5 pounds of pressure and earns a score of 5. On this test, it is possible to achieve a score of 0, indicating a complete lack of exerted pressure. Although it is meaningful to speak of a score of 0 on this test, we have to wonder about its significance. How might a score of 0 result? One way would be if the test taker genuinely had paralysis on the hand. Another way would be if the test taker was uncooperative and unwilling to comply with the demands of the task. Yet another way would be if the test taker was attempting to fake bad on the test. To summarize, nominal scales are used to label or describe values. Ordinal scales are used to provide information about the specific order of data points, mostly seen in the use of satisfaction surveys. The interval scale is used to understand the order and differences between them. The ratio scales gives more information about identity, order, and difference, plus a breakdown of the numerical detail within each data point. The next one is describing data. First is distribution. The distribution in statistics is a function that shows the possible values of a variable and the frequency with which they occur. And it is also a series of test results that are ready to be recorded or studied. Next is the raw score. It is an unchanged data from a test or observation recorded in its original form by a researcher before being subjected to statistical analysis. Next is frequency distribution. The first step is to organize the data by converting it from a random list of raw scores to something that immediately conveys a bit more information. Each score is listed along with the number of times it occurred. The results could be presented in a tabular or graphical format. So in tabular forms, we have two categories. First is the simple frequency distribution. This is to indicate the individual scores have been used and the data have not been grouped. Second is the group frequency distribution. Actual test scores are replaced by class intervals. The test user determines the number of class intervals used as well as the size or width of each class interval. The range of test scores contained in each class interval. So, in graphic forms, we have histogram, bar graph, and frequency polygon. So, a histogram is a graph that has a vertical lines drawn at the true limits of each test scores or class interval to form a series of contiguous rectangles. Test scores are plotted along the graph's horizontal axis, also known as the x-axis, while numbers indicating frequency of occurrence are plotted along the graph's vertical axis, also referred to as the ordinate or the y-axis. The bar graph is numbers presenting frequency appear on the y-axis, and references to some categorization such as yes, no, maybe, male, female that appear on the x-axis. In this case, the rectangular bars are usually not touching. So lastly is the frequency polygons. Numbers data is expressed by a solid line connecting the points where test scores or class intervals as shown on the x-axis meet frequencies as shown on the y-axis, particularly useful for comparing datasets. So frequency polygons are also a good choice for showing cumulative frequency distributions. Measures of central tendency. So it is a descriptive statistic and it is a measure of the average central tendency. Simply means what is happening in the middle of the datasets. There are different measures of central tendency, which is the mean, median, and mode. So the mean is the average and utilize all the different scores within the dataset. And because it does this, if you have particularly high score or a low score, these anomalies can affect the data. The way in which we calculate the mean is finding the total of all the scores and then dividing that by the number of scores in the sets. Next is the median. The median is the middle value, and the way in which we calculate this is to order all the value to start off with from smallest to large. If we have an even number of values, well, you simply have to take the middle two scores and average the result. So if we look at the example below, we again rearrange the data into order of magnitude, smallest to first. Only now we have to take the fifth and sixth score in our data set and average them to get a median of 55.5. Lastly, the mode. The mode is the most commonly occurring value in a distribution, greatest frequency. If more than one score with same frequency is equals to bimodal. So advantage of the mode is the mode has an advantage over the median and the mean as it can be found for both numerical and categorical or the non-numerical data. The limitations of the mode are some limitation to using the mode is in some distribution, the mode may not reflect the center of the distribution very well. That's all. Thank you.